All right, let's dive into some of the most fundamental chemistry out there. Stuff that's happening all around us and even inside of us every single second. We're going to break down the world of acids, bases, and salts.
You know, have you ever really stopped to think about why a lemon makes you pucker up with that sour taste? Or why soap feels so slippery and weird in your hands? It's not magic, I promise you. It's pure chemistry, and we're about to get right into it.
So to really get a handle on this, we've got to meet our two main players. I like to think of them as the dynamic duo of the chemical world, acids and bases. And trust me, they have some seriously different and often totally opposite personalities.
Okay, first up, acids. The name itself is a pretty big clue. It comes from the Latin word acetus, which literally means sour. Now, for the sciencey part, an acid is basically anything that lets go of hydrogen ions, those little H+ particles, when you put it in water. Think of it as their chemical signature.
And then, on the other side of the ring, you've got the bases. They do pretty much the opposite. Instead of hydrogen ions, they produce what are called hydroxide ions. That's the OH- particle. And their calling cards? Usually a bitter taste and that classic, super soapy, slippery feel.
So let's put them side by side for a second. On one team, you've got acids, sour taste, releasing those H+ ions. On the other team, bases, bitter taste, releasing OH- ions. They are perfect opposites, and this even shows up in classic chemistry tests. Acids turn blue litmus paper red, and bases flip it, turning red litmus paper blue. It's a real chemical showdown.
All right, so that's the theory. But how do we actually tell them apart in the real world, not just on paper? Well, this is where the detective work really begins. To spot an acid or a base, we use these really cool things called indicators. Think of them like little chemical spies that change their color or sometimes even their smell to reveal a solution's secret identity. Litmus paper is the famous one, of course, but you probably have an indicator in your kitchen right now. Turmeric turns this reddish-brown color if you put it in a base. And get this, some indicators, called olfactory indicators, actually change how they smell. How cool is that? Okay, so telling them apart is one thing, but what if you need to know more? What about how strong they are? I mean, there's a huge difference between the weak acid in a can of soda and, battery acid, right? So how do we measure that power?
We do it with something called the pH scale. It's just a simple number line from 0 to 14 that tells you how concentrated those hydrogen ions are. And a fun fact, the P in pH actually comes from the German word potens, which means power. So right in the middle, a 7 is perfectly neutral. Anything below 7 is an acid, and the lower the number, the stronger it is. And, you guessed it, anything above 7 is a base, with 14 being the most powerful.
So we know who they are, and we know how to measure their strength. So what happens when they actually meet? It's time to talk about reactions. The biggest, most important reaction is called neutralization. And it's exactly what it sounds like. You take an acid, you mix it with a base, and bam! They react and completely cancel each other out. And what are you left with? It's always the same two things. A salt, like in this example, sodium chloride or table salt, and plain old water. It's like they call a chemical truce. But hold on, acids don't just react with bases. Mix them with certain metals, and you get a salt plus hydrogen gas. This right here is the exact reason why people say you shouldn't keep sour foods, like curds, in copper or brass containers. And hey, ever dropped an eggshell into vinegar and watched it fizz? That's the acid reacting with the carbonates in the shell and releasing a ton of carbon dioxide gas.
So that kind of begs the question, doesn't it? What's the secret sauce here? What is it about an acid and water that gives it all these superpowers, including the ability to conduct electricity?
Well, here's the secret. When an acid dissolves in water, it releases all those positively charged hydrogen ions we talked about. Because these little ions are now totally free to move around, they can carry an electric current right through the water. I mean, that's all electricity really is, a flow of charged particles. So those ions create a highway for electricity to travel on, and that is exactly why this bulb lights right up.
Now, this is all really fascinating science, for sure, but I promise you this isn't just something that happens in a lab beaker. This chemistry is happening everywhere, every single day, and it matters to our lives a lot.
I mean, come on. Who hasn't had a really bad case of indigestion or felt that sharp, burning pain from a bee sting? Well, if you have, then you have personally experienced a real-world acid-based problem. And guess what the solution is? Neutralization. That indigestion is from way too much stomach acid. So what do? You take an antacid, which is just a mild base, to neutralize it.
A bee sting injects you with formic acid, and putting a little baking soda, a base, on it can help soothe that burn. Your toothpaste is basic to fight the acids that cause cavities. Farmers use bases to fix acidic soil so their crops will grow. See, this chemistry is literally everywhere.
Okay, we've talked a ton about acids and bases, but let's not forget about the other product of neutralization, salt. You might just think of it as something you sprinkle on your food, but common table salt is actually one of the most important industrial chemicals on the entire planet. I mean, just look at this. Simple table salt is the raw material, the starting point for making sodium hydroxide for soaps, bleaching powder for disinfecting, baking soda for our cakes, and washing soda for laundry. All of that starts with just one simple salt. It's wild.
And there are other amazing salts out there too. Take plaster of Paris. It's what's used for casts and molds. It's made by heating up a mineral called gypsum. But a special trick is that when you add water back to it, it sets into a hard solid. And that's exactly why you have to store it in a totally moisture-proof container, or it'll harden into a useless block right there in the bag.
So, when you boil it all down, what's the big takeaway here? It's that this constant dance, this push and pull between acids, bases, and salts is the invisible chemistry that is constantly shaping the world we live in.
And believe me, we've only just scratched the surface today. But now that you have the tools, what other everyday mysteries out there can you solve? Take a good look around. You'll see the whole world is your laboratory.